Alright, 4.3, product and quotient rules and higher order derivatives. So we're going to start with telling you what the product rule is. The product rule is, if I have a function, obviously, that is f of x times g of x, and we need to find a derivative of it, it's not like your sum and difference formulas that we learned about in the last section. What the derivative of this would be is, if you're multiplying two functions, it'd be f of x times the derivative of g of x plus the derivative of f of x times g of x. So all you have to do is just use this formula and you will get the derivative every time using your product rule. Alright, example time. So we have the function g of x equals 2t squared minus 3 times the quantity 4 minus t squared minus t to the fourth. So by your product rule, I'll make this the f of x function and this the g of x function, okay? Just to kind of label something. Okay. So the f of x function stays put as is, and then the g of x function, the derivative of that. So the derivative of that is going to be negative 4t to the third minus 2t. And then we're going to add to that the derivative of f of x, which is 4t, times, I'm going to go to the next line here, because I'm out of space, sorry, times 4 minus t squared minus t to the fourth. Now let's distribute and FOIL where needed. So I'm going to FOIL the first pair. That's going to get me negative 8t to the fifth plus 12t to the third minus 4t to the third plus 6t. Like terms, you're going to get negative 8t to the fifth plus 12, not 12, 8t to the third plus 6t. Now to take care of the other part, distributing that 4t. So we'll get 8t minus 4t to the third minus 4t to the fifth. So that's going to be everything here, and then we do like terms one more time, okay? And then I'm going to put them in the proper order of highest power to lowest power. Negative 8 plus negative 4 is negative 12t to the fifth, plus 4t to the third, plus 14t. And there you go. Here's the derivative of g of x. Alright, quotient rule. So this one has a little bit more to it than what product rule was. So let's say you find the derivative of this f of x divided by g of x, a function on numerator and a function on denominator. This is usually best whenever it's not just a constant on one of the numerator and denominator. It's usually easier. If it's constant on numerator and denominator, just do your typical product rule. But if you have something a little bit more than that on your numerator and denominator, use your quotient rule. So, how does it work? The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. One thing to note, with product rule you can mix and match, right? So as long as whenever we had this plus this for product rule, as long as one of these was a denominator, the other one was not denominator, the other one was a derivative, the other one was not, you're in the clear. In this case, whatever your denominator is must be first, okay, in the first pair, along with the derivative of the numerator. That must be first, okay? No other options. Okay, so keep that in mind as we are applying quotient rule, okay? And then the second pair, of course, is f of x times the derivative of the denominator, okay? And there's a subtraction sign as opposed to quotient rule when there is addition sign, okay? Alright, so here's a function that we need to use quotient rule for. So just a reminder to always hit like and subscribe to this page so you can learn more about math, calculus, trigonometry, etc. So let's apply our quotient rule. So your denominator, as we said, goes first when we're finding the derivative of using quotient rule. So it'll be x cubed plus 1 times the derivative of the numerator, which would be 1/2 x to the negative 1/2. We'll take care of that in a little bit. Minus, I'm going to keep the numerator the same, so x to the 1/2 or the square root of x times the derivative of the denominator, 3x squared. That's it. Over the denominator squared, x to the third plus 1 squared. Now to help us simplify this a little bit, what I'm going to do, I'm going to make this more proper, like we showed in the past, and to kind of help us simplify. What I'm going to do to the numerator and denominator is I want to get, when I say numerator and denominator, let me laser point what I mean by that. Numerator being this denominator and this numerator. What I'm going to do both to get rid of the denominator on the numerator right here is I'm going to multiply the top and the bottom by 2x to the 1/2. What happens when I do that? This right here becomes just 1, okay? Which is pretty neat. And then this, we're going to make that 2x to the 1, because you remember, you had exponents when you have the same base, okay? So we're going to get x to the third plus 1 minus 2x times quantity 3x squared. And then x to the third plus 1 on the denominator. And then, of course, 2x to the 1/2 here. So, simplify. That's going to get us x to the third plus 1 minus 6x cubed all over our whole denominator here. And subtract, we're going to get negative 5x to the third plus 1 all over 2x to the 1/2 times quantity x to the third plus 1 squared. And there's our answer. Okay. Anytime you have anything that you can simplify, please do. Okay. Especially when it's something in the denominator like here, and distribute out where you can. Okay. Okay, so this is ugly. Okay, this is an ugly one to do, right? So let's make it less ugly. And what we can do is, let's multiply the top and the bottom by x over x. When we do that, we're going to get 2x minus 1 over x squared minus 3. X. Okay, forget about that. Now we can use our quotient rule. And now, as you can look, right now, it looks a lot better than what we started with, right? So let's, or I should say, looks a lot better than the last problem. So numerator is going to be x squared minus 3x times 2, the derivative of the numerator, minus the numerator, 2x minus 1, times 2x minus 3, all over x squared minus 3x squared. Distribute and simplify. 2x squared minus 6x, foiling, and 4x squared. Minus 6x minus 2 is going to get us negative 8x plus 3. Whenever you do this right side, a little tip for you. Always put this in parentheses. By doing so, because you have a negative right here, and it can't just go to here. Okay, it's going to go to all, however many terms you have. Okay, so put a parenthesis, so then whenever you simplify this fully, you can go 2x squared minus 4x squared, which is negative 2x squared. Then you have negative 6x minus negative 8x, which is 2x, and minus 3. All over x squared minus 3x squared. And there is your solution. How nifty. So this section is all about higher order derivatives, okay? So we want to, in this case, find the second derivative of this function, okay? Which literally means we're just going to find a derivative twice. So the first one, we're just going to use our basic rules from the last section. And there's your first derivative, right? and then we're going to do it again to find your second derivative. Okay? Now you might ask why we are doing this. The answer to this is there actually is some uses for the second derivative. We're going to do some word problems together in class where we deal with acceleration. Okay? Now, if you remember, we talked about position previously, the position function, and how velocity is the derivative of your position function. Well, acceleration is the second derivative of your position function. Okay? So finding multiple derivatives does have a purpose, and there's going to be other purposes you're going to see later on as we keep diving into the wonderful derivatives. I appreciate watching. Have a good night, and we'll see you later. Bye-bye now.